Good day everyone. So in this video, we're going to have some examples of how we're going to use the discriminant to characterize the roots of the equation. So for our first example, we will going to use the discriminant to determine the number of solutions of the quadratic equation. Let's have our first example. For our example number 1, okay, so I have here 16x squared minus 8x plus 1 that is equal to 0. Okay, so the first thing we need to do is let us first determine our a, b, and c. Okay, so for a, we have 16. For our b, we have negative 8. And for c, that is equals to 1. Okay, then we apply now the discriminant formula, that is d is equals to b squared minus 4ac. Okay, so let's try to determine first the discriminant. So let's just substitute the values. So we have b is negative 8 squared minus 4, a is 16, then c is 1. Okay, so we have negative 8 squared, that is 64, minus 4 times 16 times 1, that is also 64. So our d is equals to 0. So what can we say about our discriminant? So if our discriminant is equals to 0, so we only have, okay, so we have only one real solution. Okay, so that's how you characterize the roots for this example. Okay, so let's have example number 2. Okay, so example number 2, let's have x squared plus 2x plus 3 that is equals to 0. So again, let us first determine the values for our a, b, and c. So a is equals to 1, b is equals to 2, and c is equals to 3. Okay, then apply the formula for discriminant, that is d is equals to b squared minus 4ac. Then substitute the values. We have b is 2 squared minus 4, a is 1, c is 3. Okay, then simplify 2 squared, that is 4, minus 4 times 1 times 3, that is 12. So our d is equals to negative 8. So we have a negative discriminant, so we could say that, okay, so we have no real solution since we have a negative discriminant, or the discriminant is less than 0. Okay, so let's have our another example. So this will be our example number 3. So example number 3, about this one. So I have here 2x squared minus 3x is equals to 4. Okay, so the first thing that we're going to do here is to make this into a standard form. Since this is not in a standard form, so we just simply transpose 4 to the other side of the equation. So it will become 2x squared minus 3x. Since this is positive 4, so it will become now negative 4, that is equals to 0. And then we proceed with determining our a, b, and c. So a is 2, b is negative 3, c is negative 4. Okay, then apply the formula. So our formula is d is equals to b squared minus 4ac. And then let's substitute the value. So we have b is negative 3 squared minus 4, a is 2, c is negative 4. Okay, then we simplify. So negative 3 squared, this is positive 9. And since we have minus or negative multiplied by a negative, so it will become positive. So 4 times 2, that is 8, times 4, that is 32. Okay, so 32. Then we add, so we have a discriminant of D is equals to 41. So what can we say about the discriminant? So since our D is greater than 0 but not a perfect square, so 41 is not a perfect square, therefore we have two real and unequal irrational solutions. So take note that I already emphasize here that we have an irrational solution. Why? Because the discriminant is not a perfect square. Okay? So that's it.